Hello, this is my geometry final project, and right now I'm going to prove the opposite sides of a polygon are congruent. So I started by writing a little transversal. This is a transversal because it intersects two pairs of parallel lines. And because of the transversal, you can now say angle ABD is congruent to BDC, and you can now say that angle DBC is congruent to angle ADB for the same reason, because they're both alternate interior angles of a transversal. Because of the transversal, you now have two triangles, and they're actually congruent to each other because of the angle-side angle conjecture. So triangle ADB is congruent to triangle CBD. So if two triangles are congruent, then all the corresponding features of those triangles are congruent. So DC equals BA and AD equals CB because they're both corresponding sides of congruent triangles. And that's it. Now you've proved that opposite sides of a polygon are congruent. So moving on, now we're going to prove that opposite sides of a polygon are parallel. Right out of the gate, we can already say that triangle ACB is congruent to triangle DBC because of side-side-side congruency. From there, we can say that angle ABC and angle DCB are congruent because of corresponding angles conjecture of congruent triangles. This is because of the transversal, which I forgot to draw, but I'm drawing it here. So the corresponding angles of congruent triangles are because of that transversal. Now we can say that line segment AB is parallel to line segment CD because of the alternate interior angles of a transversal intersecting parallel lines conjecture. Then we can say that angle ACB is congruent to angle DBC by corresponding congruent angles of congruent triangles. Now we have proved that line segment AC is parallel to line segment BD because of the alternate interior angle conjecture. And we're done. We've just proved that opposite sides of polygons are parallel. And now I'm going to show you and explain how to find the area of a regular polygon. First, I'm going to start by drawing these lines from the center point of the polygon and creating these little separated isosceles triangles. And then just a reminder, for this particular equation, n equals the number of sides. This will mainly be important later. To find the area of this polygon, you first need to find the area of one isosceles triangle. Because they're all congruent, if you find one, you're going to find the area of all. Now we're going to need to find where the apothem is. So to do this, I'm going to bisect the central angle of one of the isosceles triangles. I already did this, and it's labeled in a lowercase a at the bottom. Now we need to work on the equations. So the first one is going to be how we're going to find the area of one of the isosceles triangles. And that's going to be a equals b times h divided by 2, or I labeled this side as s and the apothem as a, or the height. And so you can also say s times a divided by 2. And then I'm just showing you clearly how those numbers and letters correlate. Now to find the area of the whole polygon, we're going to have to do the number of sides times the base times the height divided by 2, or n times s times a divided by 2. Once again, n is the number of sides. So to get this formula, a equals half AP, we must find the perimeter. And the perimeter of every triangle is equal. So to find the perimeter of the whole polygon, we must multiply one perimeter or side by the number of sides we have. So to get the final formula and the area of this polygon, you would have to do the perimeter times the apothem divided by 2, which can also be written as a times p divided by 2, which is also 1/2 of a times p. And there you go. I've now explained the area of a regular polygon and how to find it. And you can see it corresponds to our original formula. That's it. Thank you so much for listening. That was my geometry project. I hope you enjoyed it.